we are given a region through which this current density is flowing, and then we're going to calculate how much total current is flowing through two different surfaces. So let's first draw the region where the current is flowing. So in the rho direction, current is flowing between 1 and 10, and from the angle here we see it's confined to the first quadrant. So that describes this region here, and it also extends from the xy plane up to z is equal to 2. So the current that's flowing will be flowing as shown by these vectors here. So now let's sketch this surface through which we want to find how much current is flowing. So it occurs at rho equals 5, and it's confined to the first quadrant. So that's this surface that also extends from z is equal to 0 to 2 meters. To find the current flowing through a surface, we have to integrate j dot ds over that surface. The normal direction to the surface over which we are going to be integrating is in the rho direction. So our differential surface element will be rho d phi, and then in the z direction it will go a distance dz. So there's our ds, and here's the given current density. So the surface over which we are integrating always has a rho value of 5. So we could substitute 5 for rho here and here. But also notice that it doesn't matter what value we put in rho, because we have a rho in the denominator and a numerator, so they will cancel. And our current density is in amps per meter squared, and our differential surface is a meter times a meter, or meter squared, so the result of this integration will be a current, amps. So a rho dot a rho is 1, so our integrand becomes 5 d phi dz. And when we integrate that, we get pi over 2 when we integrate d phi between 0 and pi over 2, and 2 when we integrate dz between 0 and 2. So the current flowing through this surface is 5 pi amps. Now let's look at our second surface. It extends from rho equals 1 to 10 meters. Phi is constant at pi over 3. So pi over 3 would be this surface right here, extending from rho equals 1 to 10 meters, and z extends from 0 to 2 meters. So for this surface, the surface normal is in the a sub phi direction, and the current is flowing in the a sub rho direction. So no current flows through this surface.